7 data. STAT621 is in what? Is it in a mass package, right? Is it? Okay. So, and we found out that this one is, or the structure is what? It's a matrix, right? Okay. Good. So, we want to find the state with income, let's say income level. So let me, this is a matrix, so we don't expect to get, so if I want to get income, what I need to do is this. Do we all agree that this will extract income? Okay. So these are the incomes of the various states. So what I want you to do is to extract the data for all states that has income greater than 4,800. Do you understand what I say you should do? Yes, so extract the data for all states with income. So the state STAT621 data. Extract all states with income above $4,800. So in this case, what do? In order to extract it, you can't go in and be checked because we can give you a data set that's so 30,000. So you must. There's not too much. There's one that I'll post on your list. It's about credit card, and that's about 30,000. That's right. Yeah, so it's the real data on customers in Singapore. So how do you do this? If we want to select all states with income over 4,800. Yeah. You can use the if statement. So you are far ahead of us. Okay, how do you use the if? You can use if. So if income, how are you going to use the if, like income? How are you going to extract income? You have an idea about the implementation. But what else? So that's one way, a long way. What other means can we use to do it? Yes. How? How are you going to do this? Yes, how do we tell our select? Yes.
So, I want to assign this group to Y. Like the group that is the income, the state with income that is greater
said income. How do you, the income, how do you do the income greater than?
It's in square brackets.
Yes.
So like it's written on
That, like the way I've done.
greater
Greater than.
than
So it's like a statement and then
So,
another portion.
okay, so whatever you're saying, we'll do it.
Will it work?
I'm not sure. You are saying so we do it. So you said which one is here?
Yes, so
Yes.
at that point.
You put this one here.
No, let's start with a new line. First of all, I want to assign that group to
Why?
Y. Yes.
This one. So for example, Y is assigned this. Is that what you want to see?
Yes, and then
Uh-huh.
at the latter point, in the square brackets, no, not yet. In the square bracket.
Okay. In the square bracket,
Yes, after the last quotation,
yes.
yes, please. Greater than the value,
Which value? 4,000.
4,800.
Okay.
And then I can run it.
And then it's the same as running this one. And are all the states greater than, with income greater than? So we can check. They are not.
Yeah,
Have you checked? Well, let's see.
okay, so it didn't work.
Where's the income? There's 3,600 there. Yes.
So the point I was stating, for the if statement,
Mm.
we'll first of all extract the income column.
Yes.
And then we'll use the if statement. If X, or let me say for the X,
Yes.
for I in income, if I is greater than or equal to 4,000, print I else plus 10 to 7
So, this one,
Yes, so first of all extract
this.
income.
So this is income, right? Okay. And then you say we should say what? If
For I in income.
for I, like this.
Yes.
In what?
In whatever variable you assign to
Y.
Yes.
Uh-huh.
Then I think it should be semicolon or
Ah, you have not done it and you are saying
yes. Then you come down.
semicolon.
Yes.
No, like this.
Yes. So now if I is
If
I is so you want greater than or
me.
greater than 4,000 or greater than
Okay, whatever you choose. Okay, yes.
so if I is greater than 4,000,
Mm.
print I else pass.
Print.
Print I.
Is that all?
Then come down, else pass.
Else.
Yes. Pass.
What?
Either pass or continue. Pass,
Ah.
P-A-S-S.
I should write PASS
Yes.
like this. What language are you using?
So this will be able to work. Maybe the way you.
Okay, but if it is just one, you can leave it. We haven't done, we'll do conditional statement. But, well, let's see if this one works. So it works. But you are not done because I said all the information. So it's like I'm extracting the information on all states with income greater than 4,800. You were just close, but not yet. So you can use this, but that's why I said it's a long process, a long route. So whatever we did over here, this one, let's say Y, right? If remember Y is the income, right? Okay, so I'm going to do this step by step. Y is greater than 4,800. What do you think will be the answer? If we say Y is greater than 4,800. Y are values, income values. Good afternoon. Y are income values. What do you think it will be?
Because the Y is a matrix with
No, this is a vector.
Y is not defined. Y is a vector.
Y is defined.
Y is defined.
Y is what is on the board.
So it will limit us to if
And I'm saying Y greater than 4,800. What do you think will be the outcome? Yeah.
So, when I run it,
So you run it. I wanted you to. I wanted you to tell me before. Okay, so it will be true or false.
Yes.
Is that okay? Which means if it's greater than 4,800, you get true, right?
yes.
Okay. Now we can use this true or false to also extract information. In other words, the same way you were using, let's say, 1 comma within the square bracket to extract the first row. If there is a true, it will extract it. If it is false, it will not extract it. Is that okay? So that's what I wanted. So in other words, I can, because I want to take out all the rows, okay? So if I pass this here, I should extract all the data. No. That's not what I want. I'll pass this through the STAT621. So in other words, I am taking all, or actually what we are doing is that we are extracting this, but we've used Y already, so let me just use it like that. Okay, so there it is. Okay, so actually, if you don't want to use any Y or so, you can just do this. So what happens here is that take all income, right? And then income greater than, or maybe if I have done income, usually if you are naming your objects, let it be synonymous with whatever you are finding. So this one make more sense. So any income greater than what? 4,800. Remember this one gives us what? True or false. So any row, remember we also said that anything before the comma is what? Is for the rows. After the comma is for what? Columns. So it means that all rows with true will be selected. Is everybody okay? Yeah, so if we do this, and we can go and check, you see income. All the incomes are what? Greater than 4,800. Is everybody okay? All right. I can even add more. So please take your time and practice through some of these things because they are very important when you are doing programming. You don't want to be, you run one and then you go and check. You run another one, no. You automate everything. Okay, so these are some of the things you can put in to do selection and so forth. And of course, the conditional statements, if, while, repeat, and then we'll do looping for, apply, S apply, L apply, and all those statements are very important when you want to do this. Okay. So that's it with, we can actually combine, okay, and then all. Okay. So for example, if I want to select states over which has income greater than 500, 4,800. Okay, income. Let me see. Let me do another one. Let's say murder rate below 5. Oh, yeah, murder So I say murder 5 is okay, just murder. Okay, not murder. Let's say just murder. So in that case, I'm going to do states the same way we did it. So in this case, it's what? Murder. Okay. So murder will also give me all the murder. So if I want murder and murder below 5, I can do it. So it means that over here, you are going to get 2. You must satisfy both conditions to be selected, isn't it? Yeah, so we can do that as well. And if we do this, you see that all the what happened? Yeah, so here, yeah, so you see these 3 states, their incomes are over 4,800 and their murder rates are all below 5. Okay, and so forth. You can do all with just one, what do we call it? The all sign and so forth. If I copy the same thing, I hope you can make the notes on it because I have not been commenting. If I put all, what do you think will happen? Oh, I did not copy the, yeah. So here, almost, it's not a good, it's not a good, if your income is greater than or your murder rate is less than, we select you. What about, let's see, it should be double, right? Logical, okay. What else? Okay, so these are some of the things. Let me take the opportunity to talk about conditional statement. I didn't want to do all programming, but let's see. Conditional statements. Okay, so what are these? So A, we have if. So we can have if. So just if is a conditional statement. Remember, there must be some if this, then do the other one, right? Okay. Now, so let's see. If we have X is, let's say, the income. We already have income, so let me say we already have income, so there's no need. So usually, let's do if. You see, once I wrote if, it is actually waiting for a command. When you see this plus sign, it means R has not ended. It is looking for, because usually we do if else and so forth. So we also have if else. Yeah, so if else. So this is how we use if else. So if we need a test, if the test is true, this is executed. Other than that, the other one. Okay, so when we finish, we'll use the same analogy to do if condition else. This is when you have only 2 possible outcomes, right? So if you get above 50, you pass. Other than that, it's a failure. Then you can use it, right? If we have more, like the grade that we use in University of Ghana, then you cannot use if else. So in that case, we use if and else separated. So if you get a max greater than or equal to 80A. Else, if it is less than 80 and greater than 70, greater than or equal to 75, you get a B plus. And so forth. So you do this until the last one. So so let's look at this. So let's look at income. Remember, we group our observations into those who are over 4,800 income and those below what? 8,000. Okay. So if I want to display them, I can use the if else condition. If you like, you can copy over here. And so the test will be that income, income greater than what? 4,800. That's a test. This will give us true or false. Now, if it is true, this must be done. So I can if income is greater than 4,800, I can say that this is how do they even classify economy? Upper income or whatever. Let's say upper and lower. So I can write that this is upper income, which means any state, and then if it is not, what happens is what? A lower income. And why am I putting this in quotation mark? Because it's a string, so I want it to. So it means that we are going to get 36 of this lower income, upper income. Okay, so, and you can actually check with the income. I can do this, and okay, so it even brings the name. So Alabama is a lower income, and we can go back and check the actual value for Alabama. If you can check, what is it? What is the actual value for the income for Alabama? I can show it here if you.
362.
Good. So it's actually classified correctly. Is that okay? Are we there? Okay. The next one is Alaska. Alaska is 6,315. So let's check. Alaska, upper income. Yeah. So that's these are just two categories. If you are here or there, but what we are using, the test is the condition income greater than what? 4,000. If that is satisfied, whatever is here is executed. Sometimes it may be a function. We have not yet done functions, but it can be any complicated thing. Okay, where you have two branches, you can use this to do it. Any question on this? Yes.
If we have been able to extract the income greater than 4,000.
Oh, so that's what I did over here. So either you say that income is the whole of income. That's what we did over here. Right. And then if I now say that, because I will just extract only income data. Remember what we did with the search rate. Then after that, if we say income greater than this, if it's greater than that, true. If it is not, false. Okay. Enlarge it. Why have you enlarged it to fill the entire space? Yeah. Okay. Any question? Any question on this? Okay. Can we move on? So, yeah. So that is the if condition. Now, let's generate some marks and then also check whether they failed or not. Is that okay? let's generate some random marks. So scores or random scores. So how can we generate scores in an examination? Randomly. Yes. How can we generate scores in an examination? We want to, in other words, generate samples from possible scores in an examination or marks. We can use samples. Okay, from
100.
sample 100.
No. Depending on what your score range is. So if it's 1 to 100,
Yes,
that's so a range 1 is 200.
yes.
And depending on the number of students you want to generate the marks for, that will be your size.
Okay, that's good. So scores should be sample. What other way can we use to do this? So our X should be what? 1 to 100, right? And what? It won't. Well, if you want to, but no. And then size. How many scores do we? Maybe we want to generate 20 scores. Okay. So here, if we do this, I got this. Somebody will also do it and get another one. That's why he's asking whether we should set seed. We can also set the seed and then we all get the same random number generation. What else? What other way can we use to generate the scores? Random. Okay. You said random what? Function. How? But that's the one we have used. What do you mean random what function? What is random function? You are mixing programming languages together. The way you were talking about friends and past. You know Python. So that's it. It happens. When you have to use 2 or 3, sometimes you make some. You can't use random. Yes. I'm not saying, you must tell me in statistics, how can you generate, apart from this sample, that is sample from the numbers, what else can you use to generate number generator? What is number generator? Yes, you can sample from a uniform distribution. Because that one has what? Minimum and what? Maximum bar. Just that will get point something, but we can round it off. So that's one other way. So we could also have generated these scores. So let's say scores 1 from, let's say, uniform. So uniform, I'll talk about, so uniform is, let's say, R uniform, right? I'll talk about probability distributions in R. Okay, but these are basic statistics that we will get them across as we move on. So the uniform distribution, you have minimum and maximum. So if I set the maximum to 100, it means I'm simulating observation from 0 to 100. Even it means nobody can get 0. It should have been 0 to 100, right? Because I can show you some of the scripts. The attendance. Or sometimes you want somewhere to put 1, but the person has not done anything. So maybe we award 1 for attending. For attendance. Going to the exams or to write. Okay, so the uniform distribution is the random number generation is generated as that. All what I wanted was you to say that, okay, you can generate from this, so that's fine. So the minimum is 0, maximum is what? 100. Okay. Now this one, if I do it, I'm going to get point something, but if you want it to be whole numbers, in R, we can round as well. You round to some decimal places, and you can truncate. Okay, all what we do in mathematics, you can do it in R. Everything. Okay, so I can round. Okay, if you want to round, just round, right? So if you go there, you see all those rounding of numbers. We have ceiling. It means we will take the upper integer. And we have floor. We will take the lowest integer, or the integer part of the so if it is 4.7, the floor of it will be 4. If it is 4.1, the floor is still 4. But 4.1, the ceiling will be what? 5. 4.7 as well will also be 5 as well. So that's it. And you can have trunk, which is truncate, okay? And then also round. So we can round. If you are rounding, you round x digits. So if the digits is 0, it means no decimal place. Okay. And we can have significant numbers and so forth. But usually it's this floor and these are very important when you are doing simulation. So for example, you want a sample size. Okay. But if you calculate the sample size, it's maybe 2.1 or maybe 204.4. How do you do it? Then, the program you cannot select 200.4 individuals. Is that okay? There needs to be some rounding. In some cases, because you want to get a higher sample size, you round, you find a ceiling so that it will be 201. Okay, some area maybe you want the floor, then you can use it. So that's it. Other than that, your program will run into an error because you can't find 200.4 people and so forth. So whatever we do here will have so usually once we do some small, I just want us to go to the practicals so that you know the extent to which you can use whatever we are doing. But somebody asked questions, so I thought we could just bring this in and do it. Okay, so instead of this scores 1, I can put it in round, right? So my x will be this. Okay, and then I round it to digit 0. So if I do scores 1 and I display, everything is in what? Whole numbers, right? Okay, this man wanted us to set the seed. If you want to get the same results as I've got, let's just set the seed. So maybe we put in, our seed is 124. So let's all run it. You have to run. Remember that if you want to assign and display at the same time, you put all of them in parentheses, right? Okay. So let's see. Okay. You run it. Run this set the seed and run this. We should get the same thing. If we seal in 24, you see the same. If I run it several times, you'll get the same. So let's see. In some cases, you will get. So that's sampling. So even though we are doing this, we are doing sampling. Remember we talked about sampling with replacement and what? Without replacement. How do we do with replacement? Now.
I think when we have replaced, we indicate
true. This is what? False, because it's the default. Are you done? When you said the same, did you get the same thing? Who got a different? In some cases, you get, depending on the computer. Did you get the same thing? You have to run the set of C test. Have you run?
Yeah, I'm not challenge with rounding, doing the scores 1 before we come to the round.
When you are, you shouldn't be deleting You go back. As soon as you are typing round over, start typing round. Take your time. Don't type to round, yes. And look good, and then you select. Good. Okay. That's how you type. Other than that, you make mistakes. So it shows you that there is dignity. So other than that, you can also copy from the help and paste it there, then you fill it in. That's what I do. Any questions? So let's all simulate and get the scores. We are going to use the scores 1. And we want to say that if you get above 50 pass, or greater than or equal to 50 pass, other than that, what? Fail. So in that case, we can use what? If else. So if else scores is greater than 50, what do we say? Pass. Else what? Fail. If you want to do it the other way around, if else scores is less than what? 50, what would you say? Fail. Other than that, what? Pass. So whichever way we do it, we should be able to see. What do you say? Are you done? Have you been able to generate it? Not yet. How are you typing? Oh, we should bring these people. She's typing. You should always be, especially the function, so run the cycle first. Now you got the same thing. So you are done. If you are done, then I said we want to be able to say that if you get greater than or equal to 50, pass, else fail. So let's do that. So these are two options. You either pass or fail. So we can use the if else. Let's hurry up so that we can move on. If else scores 1 is greater than or equal to 50, what else? Pass. Else what? Fail. And run it and compare it with what you have. It's telling you that something is wrong. You have more brackets than you shouldn't be, parentheses, you shouldn't be doing it on your own. I will always provide you with the parentheses, then you work within it. So run it now. So if you put it, I put it in double parentheses. That means store it and also display it. You do not run the set of C's. So if you want to do it like that, you need to go back. You have to choose any number, but all of us should choose the same number. Other than that, we get it. So it could be thousands, it could be 10,000. You've got to see. You've done it. Okay, good. Yes. So because we put, yes, everything. So in this case, you can check whether, and the stores is at home. Assign store display. Okay. So let's quickly do the if else statement, pass or fail, and let's move on. But set the C so that we all get the same results. And Okay, so in that case, it's quite simple. If else, yes, those who have done it. If else cause 1 is what? Greater than or equal to what? 50. What do you say? Pass. Else what? Fail. Yeah. So fail, pass, and so forth. Okay. Okay. So let me move on. We are spending too much time here. Now we have if, else. So this is two different things. The other one we have if else together. But this one we have if else statements. So here we're going to talk about grade, right? So we want to write a function that will compute grade. So grade, let's say it's a vector. If it's a vector, then we can replicate, let's say, NA. You remember rep? It's all replicate. Okay, so let's say I want to get the 10. It means this will come in. Okay, so it's fine. Don't even replicate now. Well, I'll come back to it. It means we need else. But let's, so if, this is how we're going to do it. If scores, score 1, this won't work, right? Because we need to, okay, so let me, now I'm going to say mark. And the mark will be only a value, one value. Other than that, we won't be able to do it. We will do it later on, but we will loop it so that it's able to do for several vectors. Okay, so if mark is greater than, is greater than or equal to 80, what will be the grade? Grade will be assigned what? A. Good. Then, so this is how we do the if else statement. Else, I'm not ending here, so we do else if, then the condition. So it's if condition. So if it is just 2, it's just if, sorry, let me do the first one before I move on to the grade. The scores over here was pass or fail, right? So if you are using this, it's if the condition is scores, but this cannot do what we did over here. If scores is greater than 50, what we are going to say is that pass, else fail. So the if else statement can also be done in this way. Let's say, but that I can say, let's say comment. The comment from your teacher is what? Is pass or what? Fail. Okay. So if I do this, yes. And this is what I'm avoiding. Because the if cannot take a vector. It has to take one at a time. So later on, we will loop it and call it as a function. And then once it takes one value, it runs through it and gives us an answer, and then it takes the next one, and it takes the next one, and so forth. So, but if I say score, let's say the term score, then this will work. So I'm going to check whether the person in the 10th position. So now if I click on comment, it failed. Okay, so that's the if else, but it can only take one observation. I can check the first person. That person got 8 or something. So we expect it to be what? Fail, right? Okay. So I go to those scores. The comment is fail. which one else was pass? Let's just check. Number 3 is pass, right? So let's see whether this one too works. So let me put comment here. So essentially what is happening is that you say pass. If the condition is satisfied, you go into that curly bracket, and then you execute what is inside. Other than that, you move to the next one. Okay. But then what we are doing, so if else for 2 outcomes. So when we have only 2 outcomes only, we can use if else. But more than 2, so more than 2 outcomes. So for more than 2 outcomes, that's what we are doing now. So now, if else, still the condition. So I don't have to do this and that. It is okay to say if it is greater than or equal to 75. Because, yes.
Before you continue, the first one, the comment, is it part of the syntax or it's just you that has done it?
No, if I'm doing if else.
When we did it earlier on,
Yes.
we just stated pass or fail.
Yeah, you can put in like pass or fail. But what I've done is to assign that comment a name, an object name. Because as I said, it can be a computation. It can be mathematics computation that if the condition is this, then you put it in today's formula and calculate days. Right? Like, in finance, they call something binomial pricing model. It's like this. So if a condition is satisfied, you move, and the pricing may be some black, so it's equate, so it can be anything. So what we are doing is just a simplified form. Later on, when we have more important problems, you will be needing some of this. So it can be that X is now, let's say, I can even, there's an example that I always give. We'll do a mixture distribution, right? Okay, so I can combine 2 distributions to become what we call the mixture distribution. Okay, so I can combine, for example, exponential and gamma. We call that distribution an S gamma. So I simulate observation from exponential. I simulate observation from a gamma distribution. Okay, so I can simulate 100 observation from exponential, 100 observation from gamma. Now I need to put them together. I need 100. What I have to do is to, and you will do this, it's practical, it's a paper, so I will give it to you, then you do it. What I need to do is that if a condition is satisfied, I take observation from exponentials and bring it to the sample that I'm creating. If it is not satisfied, I take it from a gamma. So by the time I go through the 100 times, I have my new sample. That new sample will be a combination of samples from exponential and gamma, and that's what we call the S gamma. Yes, based on. And that we can use something like that. So all what we are doing is to help us in solving problems later on. And these are practical problems. As I said, but the binomial pricing model uses something like that. I don't want us to be bogged down with we need them, but it is good when you know the practical aspects. So I'll be very brief over here. Just get the concepts, and then when we get to the practical applications. Okay. So let's continue. So now, what you know is that if you have more than 2, then we need if else. Okay? But here you have to do else if. So the last condition will be else. So that's the difference here. No, else yes. If. So all after if, anything within that and the last statement must appear with else if. Then the last one will be else. So that's how we do it. So we are going through this great thing. Okay. So now if it is greater than 75, what are we going to say? No, it's not A. Here is B plus. We are using the undergraduate one, or we should use the graduate one. The graduate one, I have forgotten exactly. 75, I think, is B, right? No, it's not C. It's B. Okay. And then, okay. So I can copy this again. Please just copy. If you do one, you copy. Else, if it is greater than 70, is what? 70 is not C. Let's use anything, like maybe B minus. Is it not? There's no B plus in there. So let's check. We can easily check online. So like UG graduate grading. I know the undergraduate offered. So there it is. Are they sure? I think this is the undergrad. This one is, we don't have A minus here, my friend. That's a long time ago. Okay, so I think this is correct. 70 to 79, this is correct. So let's look at this. Okay, so C is 50 to, I think, 59. Yeah, and D will be, no, 50 to 59, yeah. No, D is actually a fail. D is what? Which is a fail, actually. So, for example, you cannot get a D and pass. It's 50 to 54. So this, for the, are they sure? Hey, we are not so much interested in it. Let's program and go. Our interest is in the programming. Okay, but let's see. We just use this as a guide. I hope they are giving us the right. 75B. Okay, so let's move on. So let's say we are on course. So this is B plus, right? And this will be B. And then the next one will be what? This should be 70. Then I do again. This should be 60. Is it 60 to 69? So then that should be it. I doubt this thing. 70 to 74. Yeah, and then 65 to 69 is C plus. 65 to 69. So this should be 65. And that should be C plus. Are you following? Are you following? Okay, then the next one will be 60, right? Then this should be what? C, I think. Then I do again, and then the next one is 55. You see, I could have added another one, which is like what we did. If it is, let me finish. And this one. You see, the first one, this also means that the mark is greater than or equal to 75 and what? Less than 80. Yeah, because if you are not less than 80, you won't even get there. So before you get out of the 80 condition, you must be greater than it, right? But if you are less than that, you cannot go past 75 unless you receive something less than 70. So that's why I'm able to not bring the two that less than 80 and greater than, yeah. But you can actually do that. But that's the implication of it. The next one is, I think, D, right? From what we did. 55 to 59 is D plus. So that one is a pass. If you even want to rewrite, we will not allow you. But this one you can rewrite. This is D, which is actually not a pass. As they say, very weak graphs. Yes.
The max, we really assign max.
We will.
You can run it before you see.
No. This one, it has to take a number. You cannot run without that actual number. So else, this is what I was talking about. Else, grade will be what? Fail. So if I am able to, I want to do this, then I need to assign a value to mark. Other than that, it won't work. So if I take mark to be, let's say, 30, right, and I run through, after that, if I call for grade, you think grade will be what? F. So it means the program is working. Let me change it to 80. If we change it to 80, grade should be what? It should be A. I can go back and change it to 70. Right, 70 should be what? B. So let's see if we get B. So it actually works. The thing about this is that we can't be going around. If we have the students in this department, then you'll be adding or writing each student mark to be checked. Later on, we'll vectorize this as a function so that when we call it, it's able to do if it's 1,000 at a go. That's what we do later on. So that's after we've done functions, and we will do this later on. Any question? Any question on this? The other, so that's a if-else condition. I don't want us to spend too much time. So 3, we can talk of repeat. So repeat is also a conditional statement. Oh, I've even, no, this will be loop, but I want, there's also, oh, this is 3, switch. There are so many of them, but I don't really use them, but it's important I just introduce you to it. So there's also switch. So let's go and check this. So switch is select one of the list of alternatives. So when I have, so I think the great thing that we are doing, we could also use switch to do it, but I won't waste our time here. When we go home, you can try and do it. So you can look at over here, and there are even examples. Okay, so center, I haven't done functions, so it will be difficult for you to, but later on, maybe when this works well when you have a function. Okay, so switch means, you see, type. I write a function, then if the type is this, calculate the mean. If it is median, calculate the median. If it is trimmed in, so if you do the center, the function name is called center, X. Then the type is mean. It will select mean and what? Execute. And so forth. So that's also a conditional statement. Some condition must be satisfied to what? To choose in between one of them. Is everybody okay? Please, are you okay? I hope so. Okay. So what I mean is that Switch, just like the name suggests, it's like you are alternating between things, right? So if you have switch on the board, you press on, off. Yeah. This allows you to choose in between what? Alternatives. Okay. So for example, here, what we were doing was that if Mark is satisfied this, we tend to give you a grade this. So we can actually put this as a switch statement. Okay, which means we'll write a function, we pass the marks through it. If it is between this, we give you this. If it is not within this, so it's the same like if conditions. But it's treated well when you know what the function is. Because usually you pass the argument through a function, and then you can use the switch to now alternate between the options available. And this is good when you have several options. So the example over there is that you want to find the function name is called center. You need to put in the function x and type. If you put in x and type, it switches what the type function is. If it is mean, which means it will correspond to the mean, it calculates the mean. But it means it will not calculate the median and all, the trend mean. That's what you switch. You cannot, when you are switching on the light, it cannot be at the middle, it's on and off at the same time. No. You must actually choose one of them. Let me see my time. I still want to treat graphics. I'll come to this. It's always some way when you are teaching this because it's a bit technical. So I don't want us to spend too much time on it. But just so you are introduced to it, you can always look to, yes.
Position of where code this thing also matters for this. Because if you run it straight forward, like bringing the grid.
You mean this one?
Yes,
This one?
Yes.
Yeah, you can get an error. You got an error, right? Yes, yeah. You can. That's why I put these ones over here. So that's a good observation. So if you look at the way I'm doing it, it can break it. Yeah, so this is how I usually will program. The curly bracket, I let the other one, then the other one starts with that, and so forth. Some also do it, but it's not good. You can do everything on a horizontal line. But it means you have, if I was teaching you and I did that, I have to be switching this back and forth for you to see. But I usually will do this. So if you want to press enter, that's what you do. In fact, I could, let's say I could do it up to the C. Then I break it down and do the other one. But I did it in such a way that each grade is on the same, a different line. So that it makes it easier for you. Yes.
So from the curly bracket, for example,
Yes.
where you have mark greater than or equal to 60.
Yes.
The curly bracket, do you press enter?
Yes, if you press enter, but sometimes you get mistakes. Because when it gets there, it's as if it has ended. Now there's a new, what do you call it? A curly bracket. So I usually will put it on the condition. After the condition, you put it there. But you can then press enter because it has opened a new bracket. It will always look for the end date. But when you bring it and it ends it, then R is in the dilemma whether to end there or not. Then sometimes you get mistakes.
So which one are you?
Like this. This is how I
do
do
you
it.
count down?
Oh, you just press enter.
Okay.
Yes, where the cursor is, if I press enter, it will go down. Then Control Z comes up. But that's how I program, and you will not get any mistakes with it at all. Okay, so let me also next. So then I need to go here and change the topic to what did I? Conditional statement and loops, so that I can quickly talk about loops as well. Okay, so switch. So let me move on to loops. So looping in R. This is also a very important topic if you want to be able to program in R. Okay. There's a video on apply families. The apply families. Please make sure you take your time and watch that video. It will help you later on. So loops. How do we do looping in R? Well, there are several of them. We have the for loop. We have repeat. We have while. What again? For repeat. Okay, maybe I'll get the rest. Okay, so what is a for loop? First of all, you can look for, so for is a keyword in R, right? You cannot use it to do your, so the for loop, sorry, is it's a keyword in R. Okay. Okay. So what actually happens is that if I have you, it goes like this. You need an index, right? Okay. That index can be something like, let's say 1 in, let's say 10, which means 1, 2, 3 up to 10. I can also pass in any vector or a list. Okay, so let's say we did income, right? Okay, so I can say that for I in some index, okay, you do something. So that's the structure. Okay, this, it could be J, it could be anything, because it's dummy. Whatever it takes over here, I can do J in, but this is a keyword. And this is a vector or the index that I'm talking about. Okay, so I can say that for I in, let's say, income, we did income, right? Yeah. We can, somebody say print. We can multiply 2, okay, by income I. And then we end it. What we are doing simply is that, remember income, okay, if I take 1 over here, it means, sorry, this won't work. Let me just say 10. Okay. So if I do this, what no, 1 to 10. If I do, what I simply mean is that if I take I will first take the value 1 and then goes to income. It means it will take the first income and multiply it by 2. And the results, we can actually store it. Or we can just display it like this. If I want to store it, it means I must also have a vector which will be assigned this place value. So the next one will be 2, the next one will be 3, the next one will be 4, the next one will be 5, until we get to 10. If I want to store this, I can also say that, let's say, double income. So D income is assigned replicate. You remember replicate? NA. Then in this case 10. So it means I'll have NA is 10, right? Okay. So when I come here, what I'm going to do is that I'll say D income oh sorry, D income I will be assigned what is here. So which means every time I take I, it goes to the, let's just do it so that you see how this is. But that's the structure. You need 4 with for I in, and as I said, it can be anything. For I in, let's say 1 to 10, okay, which means I need to D income, right? D underscore income is assigned replicate. I can even do NA length of income, which means I'm going to get 36 NAs, right? NA 36. Okay. Now, if I'm doing this, it means D income I, which is that to take the first one, so income 1, it is now going to be replaced with what? Income 2 times what? Income. Income I. Okay. Okay. Now, if I display income, you will see that the first 10 observations have been what? It's been multiplied by 2 and it has done what? Replace it. If I want all of them, what do you think I should do? If I want to replace all of them by the double of the income, what should I do? No. The NA is just a placeholder. You cannot use a for loop to create, because it is, otherwise it will override. It will, if I take the I off, what is going to happen is that when we finish, we'll get 1 off, which is the last one. Let me do it for you to see. Let me take out, what's the D income, right? So let me remove D income. Or let me do it again, replicate, okay. Then I take this out. Okay, so I do this. Now I want to see the income. You see, it's only the 10th observation. Because there's no, every time it will just override whatever you have over there. But if I first do this, look at it. The income is how many? 36. Okay. If I run this, what it's telling now to do is that take the first one, assign it to the income. So we are overriding everything in that income, and it will continue until the last one. So what we see is the last one. If you check the data, the income for Georgia will be, I think, 4,000 and something. You can check it. Yeah. Yeah. So, but that's not what we want. We want to be able to take the variable income and double it. So that's why we bring this one over here, like this. I. So but what I was asking you was that then the 10 should be what? The length of what? The income. Is that okay? In that case, we'll replace all of it, not just part. What I've done is just to replace what? The first 10 observations. I can even do sequence and only replace those in, what is it? The, let's say, odd numbers by 2 and even numbers by, so, I mean, you can do all this if you want. But if we want to do all of them, we will do length of what? D income. Okay, and then if we do this, all of it, if we call D income now, every Oh, sorry. I did not. Okay. I need to do this again. Because it was only one observation. Now, if I call the income, all of it will appear. Yes. So these are very important. They are very simple. Okay, but it really helps us in evaluating, especially when you have to do it repeatedly and so forth. So that's the for loop, which is the first one. So for loop A. Then, yes. Please go ahead. Yes, please. I'm recording it. All right. Then repeat. So repeat. We all know what repeat is, isn't it? So in now, we can repeat until some condition is satisfied or not satisfied. Then we get off it. So that's also a very important function. And we have replicate, well, repeat. Yes.
Please, can you go over
the 4? It takes okay, so you need to have an index. Okay, that index may not be 1, 2, 3. No, it can be actual vector. So I could also take the income, and each of them I multiply it by a value, or I create something. I don't want us to draw so much. I just want us to know how it is. We will do practical stuff. When we have done with functions, we'll be able to take, because within functions, then you can do some of these things. Okay. Whatever is happening is that the condition is that take some variable. That variable should take the values within the index, and then when you go in here, it can compute something. But it will be repeated until it exhausts all the observations within that function. Okay.
Sir,
Yes.
please, I want to suggest that
Yes.
when you write a code
Yes.
and you want to do addition, let's copy it and do addition. Because it's like sometimes I want to compare the previous one, then you already clean what was there already. Because
As
of
a
that,
copy,
it's like-
okay.
yes.
All right, okay. Yeah, usually I'll come back to make comments and so forth. Something doesn't work, then yeah, I clean it or something. But we'll see. Okay, so let me see why repeat is not working. So repeat function in R. Yeah, repeat. So if you, let's see. So there's replicate and then repeat. Now, let's look at this. So, yeah, the repeat form is of this. So you repeat some statement. If the condition is satisfied, you stop and then you get out of it. Okay. Now, let's see if this is a good. Usually it's not. That's why I don't really like teaching these kind of things until you are in a programming environment and then you encounter something that you have to do it. So this example, if we look at it, it says we are repeating repeat loop. So you are printing x. Okay, if x is greater than 4, as soon as x is greater than 4, what do? You stop. Okay, so if you have sometimes, that's why basically you won't encounter this until I'll show you some work that I'm doing, maybe that one. You've heard of truncation before? Not truncation. What does it mean? To truncate. Don't use the same word to explain. They say you are begging the question. We are asking you the same question, then you use the same words of the question to answer.
To trim something.
To
Trim.
trim, okay. Well, you get. So, what does it mean practically? To cut off something, yeah. So, in practice, how do you simulate truncated samples? Okay. So, usually you have two random variables. You are interested in X, right? Okay, but X is truncated by another variable Y. Okay, so the way it works is that I will only observe X if its value is less than the value of Y. Is everybody okay? It's not? Okay, so I can say I'm creating truncated sample over here. These are my X. I'm interested in their ages. It is being truncated by the opposite number over here. So, is everybody okay? These are the truncation variable. This is the variable I'm interested in. Okay. So, I get his age. If his age is less than his age, I will record his age. Then I come. If her age is no less than this, I won't record her age. Then I move on to the next person. That's truncation. That is different from censoring. What about censoring? Please, do you now understand the concept of truncation? Something is truncating whatever you are doing, right? Okay. But in statistics, we do it randomly. So you observe the things at the same time. It could be a factory, right? And the product is only sent if, let's say, the volume is less than a particular one that comes out. So if there are two machines, this one comes. Sometimes maybe you are merging them to form another, maybe beer or something. So what they do is that what is coming here should always be less than this. If it is not, you have to send it back for it to be refilled. That's what we mean by truncation. And it really happens. So that's one area of statistics as well. Truncation. It's different from censoring.
So, sir, if I understand what you are saying,
yes.
They are saying that we are dealing with like more than one group.
Yeah, two groups usually.
Prerequisite requirements.
Yes.
That it will cease at that point.
Not that easy to go on, but I will we will not observe it. That observation, if we say we will not observe, it's not like you are not looking. It means maybe if it's a Unilever, that product will not proceed again. In other words, you are not sending it to the market. Do you get what I'm saying? They can do some, maybe milk. It has a combination of this and that. But this must always be, a lesser quantity than this one. So if at the point I'm a production manager and it comes, I weigh this one is greater than this one, I merge it, then we get the next product. If it comes and they are equal, maybe I merge it. But as soon as it comes and this one is more than this, you do not. Okay, it's in production. They observe it. So that's truncation. Is everybody okay? Is everybody okay with it? Because I'm moving on to censoring. It's related but not the same. Can I move on?
So, sir, with the truncation, as you do the comparison,
yes.
You are moving on.
Yes, you move on.
Observation, you observe, you kind of record whatever you are mining.
Yes.
But then you move on.
Yes, you move on.
You don't stop.
Yes. So I'll tell you the problem. So if I ask you to now simulate or obtain 100 observations, or I come to the factory and I say, today I want, let's say, 100 buckets of paint. Okay, of a particular color. Remember, colors you mix them up and you get another color. Okay, so this one will produce, and it comes, you mix them together. So if it comes and this one is more than that, it means you will not mix. Maybe you push it to another, and then it goes round the cycle and come back again. Okay, so it means that if I want 100 pieces back here, what it means is that if all the 100 that are coming satisfy that condition that they should be less than that, you have the 100, you go away. Is everybody okay? Now, if one doesn't satisfy the condition, it means actually that day you will do more than 100 to actually get the 100 that is required. Because once one doesn't satisfy that condition, it is reverted to wherever it came from. It means your sample that you are sending will be 99. So you need additional one. So the trial now is 101. If that is not satisfied, you send it back. If it comes again, 102. So it continues. So, are you okay with it? It's a problem. So all these things you can use now to do some of these things. And that's why we are going through all these conditions. Okay. Remember the repeat, we do it until a certain condition is satisfied. Okay. There's the opposite of it, which is while. Now the while will take the condition. So if the condition is satisfied, you do this. You do it and come back and come back and come back until the condition is not satisfied. Then you go out. Is that okay? So the repeat is that do this until this condition is satisfied. Then you opt out. The while will be that while this condition is satisfied, do this. And then until such a time that that condition is not satisfied, then you opt out. Okay. So I'll show you what, but I'll give it to you as an assignment later on. So let me give you a hint. So I'll show you where this truncation is being done. So you see a practical example. So this is so look over here. If you look over here, you see here, you see the condition over there. What do you think will be the outcome? X and Y pray, they are all values. So what will be the outcome of what is inside? Just what is inside this one? You will get true or false because it is whether X pray is less or equal to Y pray. That's the truncation I'm talking about. Okay. So if it is true or false, it means it will take all X's. This will select all X's, in which case this condition is satisfied. Are you okay? That's what we just did with the income one. But this is what we mean by the truncation, which means X is being truncated by what? Y. Now, the same way, I need that Y values because look at what we were doing. Your age is less than this age, so we choose you, right? Her age is not, so we leave her out, and then we come here. Maybe younger than this, so we retain, and so forth and so forth and so forth. Now, it means that when I do this, are you less than, or this is true, this is false, this is true, this, and so forth. So now, when I pass the true or false into this, I select all those whose ages were less than their counterparty. And then when I come here and I put the same true or false here, I also select all those over here whose ages are what? Greater than over here. That's what this is talking about. Okay. All right. So that's the truncated plan. But remember that if I want 10 people, maybe I'll end up with only 3. Which means I need to call in now more students. That's the production one I was talking about. I need to call in more students. So 2 of them pair, they come and then I check. If they satisfy, I add. If they not satisfy, so I'll do until I get 10 students whose ages are less than those who were then the condition is satisfied. Okay. So if you look over here, if you look at this one, you see while X sub is greater than Y sub, you do. Until this condition is not satisfied, then you go out. This is opposite of the repeat. If it is over a repeat, we will do it until that condition is satisfied. Then we stop. So I want to move on because, as I said, this is a bit technical, but it is when you are solving problems like this, then you need. So when you are treating it in isolation, it's a bit not pleasant to teach. But if you get the concept and some of the applications we can use it for, then it really helps you to do it. And you see those 8 conditions over there. Yeah, what we are left with is actually function. And then you'll be able to understand most of these things that I'm doing. Well, that's a practical application. Okay. Now, let me take the opportunity to talk about censoring. So, censoring is almost the same as this one, right? But when we say censoring, it means that we stop at a point, and as soon as we stop there, the value, we have a variable you are interested in, which is censored by another variable. That variable may be a constant or it may be random. Okay, so I'll give you an example. Now, we may decide to follow people living with HIV from now until the next 10 years. And then we'll be interested in their survival time. Okay, so when we start from now, the largest survival time we can get is 10. Does that mean all of them will die within the 10 years? No. Some can even join along the way. We recruit people, maybe the 8th year we recruit you, and then you join. It means we can only observe you for 2 years. Okay, the person is still alive. So censoring allows us to now give them the maximum age they have attained, which is maximum 10. But we still want to proceed and look into the future. So that is censoring. Remember, the truncation is different. The truncation, you don't take the Y values. We only read you if your age is less than this one. If it was censoring, the one that we are discarding will not be discarded. Her age will be, her age will be given to her. Because that's the maximum you can attain. So in censoring, when it is random, you also simulate the same thing, the same way. But if your age is now greater than the one censoring you, we will give you the censoring age. It's just that you have not died. So those, when we stop at the 10th year, all those living, we say they have been censored. And in books, that's where you see plus. Yeah, so 10 plus, then it means the person is still alive. 2 plus, it means you join in the 8th year. This is your 2nd year. 1 plus, it means you join in what? The 9th year. So I have a PhD student whose work, which we are still struggling with, is this. So I'll show you the concept. It's quite a simple concept, but the technicalities in there is quite. Okay, so this is in HR, right? So you have a large construction company which are into buildings and roads, estates, and so forth. Now, some of the machinery they use are imported from Israel and so forth. So it means that some of them you have to train people, send them there to train them. Then they come to Ghana. When they come to Ghana, you can't pay them like you pay them in Israel or South Africa or Dubai or India and so forth. So by the time you realize the person is wrong. Okay, because I mean, you can check on the internet and get similar. Maybe they are paying you like and the private, and you cannot bond like the government school. Yeah, so they bond, but I mean, yeah, so as an HR person, if any of them leaves, you are in trouble because you now have to scramble and to get some, otherwise you lose your contract. So it's a very, I mean, a big problem that needs to be solved. Now, they have so much data. So, for example, if you take an employee, within the month, you check whether, let's say, status, right? So, the status, if it is 0, the person is still there. I can check, let's say, leave for the month, maybe 1 or 0, meaning no leave. Even the leave, they have sick leave, they have overtime, number of time you came to work, and so forth, age, and so forth. So every month you have this. The next month you have also that. The next month you have also that. And so forth to, let's say, so we end up at a point. Let's say, in his case, 2022. So you have data, I think, 18 months backwards. Okay. Now, what it means is that we want to be able to use the data. If you take somebody's own, maybe like that, and then here the person has 1. If you have 1, it curtails because if you have left the organization, you can't observe anything again. So it stops. Okay. So, what we want to do is to be able to now predict when an employee is likely to leave the company. Okay, so if you're able to do this, you build a model to do this. And we are doing so based on some of the characteristics of them. So you know that, well, if the person starts getting leaves, sick leave, so maybe the person is traveling to go for an interview. And so forth. So, I mean, the idea is to build a model that will be able to predict the time. Okay. So, when we started, it's like this. You see, if you have done logistic regression, if you look at this, and this is 1 employee, and I have several of them. So, when I take 1 month's data, I can actually fit a sort of a binary logistic regression framework or binary regression framework, such that I can now predict what is the probability that you stay or not, an employee stay or not. Okay, so it means I'll get probability. That probability, I can now translate it into either 0 or 1. The 1 and 0 are not numbers. 0 means you are still in employment, 1 means you are leaving. So that's a binary, like the if else statement we were doing, right? Okay. Now, but that's just for months. What actually we want to do is to be able to know when you are leaving. So it means that I can now start counting the months. This is the first month, second, third, fourth. I want to be able to put probabilities on it to be able to know that, well, at this month there's a high probability that this person will leave the organization. Okay, once, let's say you set a threshold, if it is greater than 70%, then it means you must engage a person. Either, then the HR issues comes in. You're a statistician, you won't be able to know whatever. But if the HR person knows that there is a 70% chance that this person will leave, either you start looking for somebody, or you start training somebody to replace the person, or you engage a person to maybe increase the salary, and so forth. You don't wait till, you know, and that's an interesting. So essentially, it's what we are developing as a hybrid logistic geometric regression. So this part is a geometric regression because we are counting until the month that the person exits. That's a geometric random variable. But this random variable is being influenced by other variables. So the way we do it is that once we get this one, we are going to get probabilities, the probability of you leaving, this employee leaving for each month. And that probabilities now becomes our, the covariate in our, so geometric, we actually have a regression component. which is called geometric regression. Okay. So why am I talking about this? All these things you need how to do it. And for us to even arrange this data into that form, that's why I taught data structures. And it wasn't an easy thing. Because you have huge data set and you are rounding them off, combining here and there, and changing the structure so that you will be able to fit your distributions and so forth. But we haven't finished. Still we are yeah, so that's it. That's a PhD, so you need to encounter problems. Other than that, it's not. Yeah. But it's quite an interesting stuff. So I think I've explained this, and then, so more or less, if you look at this, there's also censoring. The censoring part is that at 2022, beyond 2022, you don't have any information on the employee. What we are trying to do is that we should be able to forecast beyond the 2022 for any employee. Okay, but currently, when we fit the model, we're able to predict, but it ends at the 18 month, which is expected. What we are left to is now if we are able to introduce censoring, then the maximum you can get is 18, but the censoring will now help us to project beyond the 18. And that's where he is now. Yeah, so that's censoring in real life. That it ends over there, and all the variables are now sort of giving that maximum value that you can. That's censoring. If it was the, what do we call it, the truncation, we will only observe you if you satisfy that condition. Okay. We also have left truncation is mostly done. Left truncation, right censored, right? So the left truncation, what I talked about is right truncation, right? You truncate it at the right side. We can also truncate it on the left side, which means we only observe you if you are greater than a particular value. And in environmental science, they do so, right? You have a machine that has a minimum, let's say, resolution level, or it is unable to measure if it is below a particular measurement. Yeah, so we only, if you are below that, we can't measure you. So what else? We leave you out. Yeah. The only other thing you can do, if you want to, is to censor. If you are censoring, then you give it the last value that you can measure, which means you can also go beyond that last value, which is left censored, and so forth. Yeah. So these are some of the concepts you can, but I know you do survival analysis. So if you are doing survival analysis, you will tend to go through some of this from this stuff. Okay, so let's move on. So those are the type of, so I won't go through this other than to also say that you have while, but I've shown you an example of while. So we have while statement. Okay. So the difference between repeat, you repeat observation until a certain condition is satisfied. But the censoring, sorry, I said censoring, the while, you do it while that condition is satisfied. As soon as the condition is not satisfied, you move on. You exit the group. So that's the difference. Okay. So that's it with conditional and looping in R. So next, I'll talk about graphics in R, so that we can now enjoy some of the amazing graphs you have in R. I must say that what I'm going to teach over here are just the basis. Okay, just the basis in graphics. If you want an extended form, please use ggplot package. We are not going to go through them because we won't have time. ggplot. Before you do so, it will be good that you learn, you check DPLYR, TDVerse, what else, etc. Yeah. So these packages will extend all the things we are doing. But once you have these bases, you can always build upon it. If I bring in ggplot2 and so forth, we won't finish. But we will talk about the basic plots that you need to work. These are, the ggplots are elegant graphics. Okay, so for example, if we do a bar chart here, you can get a bar chart in ggplot2 that is even more elegant. We'll do pie chart, you can get them in R. We'll do plots, you can get them, you can get them in the base packages, and then when you go to ggplot2, you get elegant graphics. The good thing about ggplot2 and R plotting in general is that, look, whenever you find yourself or wherever area you find yourself, you can adapt plot to suit whatever you are doing. So I always say that if you go here, this is Apis, right? This is steady insect. Okay. So if we were to plot, let's say, a bar chart for the weight of, let's say, soldier flies. And you do this for, let's say, male and female, right? So this is a male, this is a female. Okay. Well, they are bars. But it will be interesting if these bars are drawn or colored insects actually. You can actually use the insects, okay, to pile up to form your bars. So instead of bars being this, you have, as for drawing, I don't know how to draw. So these are your insects. Or maybe crude, as for that one I can. So maybe crude oil import, okay, and export. In Ghana, we import and export as well. Because what we produce, they say our refinery cannot do. Okay. So import and then export. Usually what we import is more than what we export, right? Okay. So instead of doing this, we are actually using the barrels, okay, to do our plots. Okay. So, well, then the import will be more, right? Even this one, I'm struggling. Okay. So they are more. Okay, so let's say if you are the statistician and let's say NPA, then you are going to explain this to if you go with this bar and the other person comes with this colored nicely in black, and they are to give you consultancy, they will go for the other one. Then it's just Islamic, right? Yeah, so you can use to adapt your graph to suit any situation that you want to. So there's a book, I think it's Plotting and so there's a book in now that you can use some of these. So I'm going to teach the basic one, but it's up to you to, especially when you are, impress your bosses, so that they know that now you are doing effort. Your reports must be done, especially graphs. Let it be very, very, very. Or when you go for conferences and so forth. So you do your thesis, there's a conference, you go and present. By the time you realize somebody is now calling you to give you funding to do PhD. That's what happens if you do. But you must really do graphs. So please take this serious and research more into it. I'll look for the books and send it to you on the pages. Okay. All right. So to do this, remember that data is grouped into what? Categorical and what? Quantitative. When you have quantitative variable, we know the type of graphs we can use to describe them. When we have qualitative variable, we know the type of graphs we can also use to do them. Okay, so we'll first start with qualitative variables. When we have qualitative data. So the first one is what? Is bar chart, right? And that's what you were doing, right? So if I give you raw data, so the concept in now is just like the way we compute our, if I ask you, so I give you data on gender. So the first one, gender of the sex of the soldier fly, female, male, female, female, male, female, male, and so forth. So I can give you this like this. How do you now get a graph? If you were to do it, sketch it in your books. How are you going to do it? We group them. Okay. Okay. Yeah. So actually we need to get what we call the frequency table, right? Okay, so we'll get the sex. So we have male, female. Then we can even tally when we are doing it, that, and then that, and so forth, right? Okay, after that we get what? Frequency, isn't it?
Yes.
Okay, good. So maybe this is 7, this is like that. Okay. If we want percent bar chart, we can divide all this by what? The total, isn't it? Yeah, and then we get relative frequencies and so forth. So, or we can express it in what? Percentages as well. And so, yes.
Please, I want to find out in R.
Yes.
Do we have just like in spreadsheet?
Yes.
If you want to, maybe we are tackling.
Hey, that reminds me. Did I teach you how to import data? Not yet. We've done that.
We've done it.
From Excel.
Yes.
Yeah. Good. Yeah, please.
So maybe we are dealing with graphics in R.
Yes.
So we can be in the sheet 1.
Yes.
Where we have all the notes, all our graphs.
Yes.
Then we move to
Sheet
the
2.
other sheet 2. We have another topic that you are teaching us.
Yes.
Also in sheet 2, sheet 3, and so
Yeah,
on.
I will do that in the form of a data structure. So what you are calling a sheet, it can be under a list. So I can have, remember a list is a vector, but it can contain any data structure or any data type. So I can have one list. The first object will be maybe some data frame on data on regions, which means within that I have region 1, region 2, up to region 16. I go to the next object, it may be data on the African countries. The next one may be that of other, sorry, I need to take this call from the exam student. So, hello? Yes. sorry. Okay, can we? Where was I? Was I trying to answer a question? You asked a question.
Yes.
Did I answer you? Or no? Or you two, you have forgotten?
No, I have not forgotten.
Okay, yes.
So you said you can create it in lists.
Yes, in a list, yeah. So the list can be, you know, it can contain all your files at the workplace. So I'm dealing with company A, their data is here. Company B, their data is here, company, and so forth. So the way you do things in Excel sheet that you can do, let's say if I'm teaching, I can open one Excel sheet for results. STAT621, it's the same thing. But in R, you can do it in a list. Yeah.
Will it take us through or later?
I've already done that. We created a list. If I should go back, look over here. Okay, so if you come here, list. Okay. So you see what we did over here. It's in the same form as the question you are asking. I did a vector age. The next one was a vector in character. The next one is a matrix. The next one is a data frame. The next one is also a data frame. I can put all these lists in my list 2. And this list 1 will be part of the new list I create. So that's the concept you use to do it. So if you have dash data, that will be a data frame. So that can be one object in your list, the next one, the next one, the next one, and so forth. Yeah.
So sir, having created this, if you want to, for example, metrics,
Yes.
pop income, how do you?
Oh, that is subscripting. That's what we did over here. We can use the $sign, which is the best, or we can also go in and use my list. I don't know if, I think I did not, but okay, let me go back to your folder and get that one because we saved it the last time and show you. Maybe that will help me to answer your question. No, this is. Okay, so my list is there. Okay, now your question, you said if we want to get pop income, right? What do we do? Is that your question?
Yes.
Okay, so we will go here. That is subscripting. The question or selecting objects from your list. So I'll put a $sign here. Pop income was given to the matrix, right? Pop, yes, it's given. So I just select this. If I display this, that's it. That's it. Okay, so that may be one company's data. Then if I move to, let's say, data frame, that's also another company. That's how you organize which files or data set in that. So what we did is very important, as I was telling you. The data structures are very important. That this one, in this work that we did, we spent like almost 6 months, you know, in the data wranglings to get it in a form that we actually wanted. Yeah. So it's very important that you do it. But I mean, unfortunately, you can't be teaching because they usually will come when you face a problem in many forms. But the good thing is that get the basis, and once you encounter a problem, you sit back and try to resolve it based on all what you know. Okay. Okay. So let's look at, there's a data set called survey. So let's look at it. It says analysis of complex or survey samples. Okay. So let's look at the structure of survey. Oh, no, there's this one is a package. But there's a survey data in which package? I think it's mass, right? Mass. Okay, so let's see. There we go. So please have you, so click on mass or get mass in your environment and let's look at survey. So student survey data. So what is the structure of the, if I ask you what is the structure of the data, if you use STR, it will tell you what it is. But the help files also helps you to know the structure of this data, because each of them will help tell you that this is what a data frame, right? It has 237 observations of what? 12 variables. Is that okay? Okay, good. Now the variables, the first one is all sex, which is like what we are doing. Is that okay? So the question is, how do we now create a bar chart or a pie chart for this? So if I call survey, right, and I select sex, and I display it, I have male, female, male, female, male, female, like this, 237 times. Right. Okay. To get bar chart, as we were doing, you need to tabulate, right? And get a frequency table. So now, to get a frequency table, you use table. Right? So if we get table and we put in sex, survey sex, it will tell us how many are males, how many are what? Female. So in this case, they are exactly 118. So how come? Ah, okay. Please, have you seen this one?
Yeah.
What does it mean?
We don't have a D sample in that particular
Yeah.
entry.
Okay, so what is the total? Two 236. So you see what is happening. One of them, we had no information on the gender, right? Sorry, the sex. So that's why the sample size in the description, we had how many? 237 observations. Because there was a missing data, we have all 236. Is everybody okay? So you have to, because this has implication on some subsequent computations you are going to do. But the sample size is reduced by what? 1. Okay. Now, so I can call this F tab, which is frequency table, right? Yes.
If we were the Rhoda, please, I request that why don't you remove the table and then come to the next one so that we can follow it.
So you can follow?
Yes.
Oh, this one I was just doing an assignment.
This one you are just bringing.
Okay, all right. So what I did was this, that yeah, so I can put a comment, assign table a name, right? So assign the frequency table. Table a name. Okay, and that's it. So that's the F table. Now, because there's 118, for such, if what we want to do is to be able to analyze this data, and you find out that there are equal number of males and females, there is no need for any graph. Is that okay? because you can easily say it. If you plot a graph, you are going to say the same thing, so there's no need. Is that okay? Because in statistics, you have to, because you may have so many categorical variables that you need to talk about it. But the graphs are limited. You can do bar chart, maybe dot plot. Okay, so you have to mix this with tables, percentages, and so forth. Okay, so if it is equal, there is no need. You just say that there is an equal number of what, so and so in this, and then you move on. That's it. So those are some of the strategies you use in analyzing data. Otherwise, you will be too repetitive in your analysis. So this one, I won't bother. We move on. Okay. Now, what other variables do we have in this that are categorical? We have clap. Let's go here and see what clap is. Clap is clap your hands. Which hand is on top? So they ask students to clap their hands. Some will do it like this, some like that, some like this. Do you get it? And then they recorded it. Okay. So let's see that of clap. So it means I'll just go here and put the dollar sign. Oh. Yes, and then I get clap. So F tab clap, maybe like that. And then I display it. This will make sense, right? Okay, so if we want a graph, we can use this because this will know that most people use their right hands to clap. Okay, their right hands are on top, so like this. And that is true because if you are right-handed and they say clap, the tendency is that when we go to church, we go like this. Okay, if the person is left, is like this. But left-handedness, there are not many. She's also left-handed. Okay, and so forth. Okay, so let's see. Now, one more thing. We can get the relative frequency by dividing this by the total. How do we get the total? The total, we can do the sum of the table, right? Because the table will give us what? The frequency table. So if I put sum in there, it's going to give me the number of what? Observations. 236. Which means they don't consider that missing data. Right? Okay, so let's look at this. If I write, okay. So in terms of percentages, about 62% of them clapped with their right hand on top. 21%. And so when you are doing this, you also have to be strategic. Okay, you cannot call all the percentages and then you want to talk about each percentages. You are working through the data again. We want you to comment on the way students clap. You've gotten the percentages. They are 3. One is 62%. One is 22%. If you now say that 62% of the students clap with their right hand on top, 21 clap with their left hand on top, and 16, none. You have not said anything. You are not putting any meaning onto the information. You are just recapping what the data, the calculations are. But if I now, because sometimes you have to do it, then someone that have knowledge, this one, maybe psychology or sociology, will now take it and put some sociological context on it. So as a statistician, all what you have to say is that, well, maybe majority of the students clap with their, you are putting interpretation on the data. But to report 62, that's not an interpretation. Sometimes. No, sometimes you can use the values because you have to do several of them. As I said, you shift the way you analyze, otherwise you'll be repetitive.
This one, you can see more than 50% of the
Yes. Okay. Sometimes somebody may be interested in, maybe they are working on those who are left-handed. Okay, so in that case, I can now say that more than 50% or close over 60% of your students clap with your right hands on top. With regard to those who are left-handed, it's only about 16%. The population. So you mention it because that is what you are interested in. And then we leave those neither out. But if it is just some passing variable, I can just, if I know that more than 60% use their right hand, then the remaining 40% I may be silent on them because they either you are left-handed or both, and so forth. So those are some of the tricks you have to use in analyzing the data. If the percentages are very important for people to now make decisions, then you report them as it is. Okay. All right. So now let's move on. So for the bar chart, to create the bar chart, we use bar plot. Okay, so we cannot finish with this, because there are several arguments that you can look at. Okay, and that's I said, this is even the basic plot. Okay, several arguments to help you. Okay. So for example, if you look at Horace, remember sometimes when you look at plot, you see that the bar plots are not vertical, they are horizontal. In which I'll show you maybe some reports from Ghana Statistical Service. You see some of them. Now, so if we want to do that, Horace by default is vertical. If we say true, it will be done that way. And so forth. So there are so many, and what have you, all these are there for you to check. But we can't, as I said, we will spend all our time on bar plots. So we'll just do the basics and then we move on. Okay, so let's see. So to do this, I can just bring this. Okay. Height. So that is the height of the bars. So the height, I can say is what? The plot equal to the table that you have. And then I do it. So it's like this. Okay. This is not nice. I don't have colors. The bars are also not tall enough to fill the entire space. So I'll close the margins. This is margin. So just do that. And then if I plot again, I have that one. So let me make comments. So what we do here is to close the 1-1 is to close the area on the X2 and then Y2. The X2 axis is the one on top and the Y2 axis is the one on the right. So there you don't need those spaces. So if you look at my graphs, you see this space. I don't need it over there because you don't need to put a title here unless it's a presentation that you are making. Let's say you say you have to review a paper and you are making a presentation. You can put a title on top here, but in your thesis there's no need. Okay, or in report there's no need. Okay, so we can close that area and then also the one over here. And if you do that, that's what I use the
That's the meaning of bar.
No, the ma. The pa is to set the parameter of the plotting area. The parameters, and that's, I think, somebody's thesis. So it has so many. That's to help us in plotting. Pa, if you look at it. Okay, so there it is, set or query graphical parameters. And there are so many. You can how to change as whether to get this and so forth. All of them are in there. How to divide the graph into several areas, change the font size, so many of them. I think this is somebody's thesis. Fine. Okay, so this is what I use. The power, what you see there is this. So this is the first one, this is the second one, this is the third and fourth. So you see that the third and fourth are smaller. One. It's like 1 inch, 1 inch, or whatever. So, but here you need to write the S axis. Here you need to write the Y axis. So we leave more space. That's why it's 4 and 4. So that's it. Okay. So
the 4 is measuring is it the width?
No, the space,
The space
behind it. Oh, and then that one. Yeah. But that one you need some space because you may write maybe frequency. Yes, that's it. So that's the basic bar plot. But of course, S axis is not named, Y axis is not named, right? And then we can even color this. So all those things are things you can do. So we can, if we want to get the label for X, we will say, what is this? Clap, right? What was it? So this one, you need proper clap. Which hand is on top? So you need to get some, what do we call it? Label that will actually let a graph speak by itself. Okay, you don't want to get too much labeling. It also, not even fit the area. But get some phrases that will help the audience understand what the graph is without necessarily going to read about the graph itself. Good. Hello? Yes? You have to walk. I'm teaching. All right. I'm in the other room teaching when you come. Where is Kwesi? Go to the school. If you see him, you come with him, okay? Okay, bye-bye. And take the other phone, the small one, okay? In case you need anything, you call, okay? Okay, bye-bye. All right. So let's move on. So that's then the y-axis, y-axis will be Y lab. In other words, Y label, right? And as you start typing, it will come there, you select. The Y label, we can say number of students, right? Because it's about students. So by the time we finish this, the graph itself will tell you what it is about, okay? So there. So now we have which hand is on top. Left this, right, neither this, and right that. We can move on to now color it as well. So color, we can do, you want what? Orange. So orange, and somebody said gold. Orange and gold, will you be able to differentiate? Gold. It's very almost. And then the next one is what? Maybe blue. Okay.
Color use COL, just like column.
Yes. No, that's color. So COL in plot is color. Yeah. Okay.
Yeah, I want to find out the PAR
Yes.
and the MAR. It's not linked. I don't know if you have linked it with the data. It's not linked.
No, once you run this, it resets the graphical parameter. So any graph that I do now will fit into that. So it has nothing to do with the plot itself. Yeah. Okay. So I want to also do this, that the colors, you can simulate colors from the rainbow color or select colors from the rainbow. So I want to do that as well. Okay. So how do we do that? What is happening to my... It's like something is not right. Ah, yeah. I did not copy one bracket. Okay. So now, instead of color, red, so and so, I'll choose from the rainbow. So rainbow... How many colors do I want to choose? 3. Because I have only 3 bars. So let me run this as well. And anytime I do it, I'm going to get different colors. Oh, it did not. Did it change? Yeah, so you can get 3. If I wanted to change, I will sample the colors, which means, yeah, or maybe if I choose like 6, it will just sample and choose 6, right? Yeah, but it goes back and forth. So, but that's another way that we can choose colors from the rainbow color. Okay. Any question on this? Okay. Yes. You having problem?
So say, if you have done a write-up and then insert the graph.
You want to insert a graph. You export. So here you will be writing with LaTeX. Have we run the LaTeX course for you people? Oh. Circle is supposed to do this. Usually we do it for you at a huge discount. So that by the time you start, maybe we'll do it during the... Yeah, I thought it was being run. Are you sure? Because we will usually run it before you start. Did you take part? Yeah, because you must know how to use LaTeX before your second year. But if we have not done it, then we'll do it for you during the break. Yeah, once you finish exam, there will be maybe 2. Usually when I teach, I think it's a weekend. 1 or 2 weekends is enough to let you be able to use it. Okay. So now what I can talk about is Word, right? But actually when you have a graph like this, you need to save it. Okay? If you want to save it, you click on Export. Okay, then you can save as this or save as an image, right? And you can also copy it onto your clipboard. Okay, so let's do the save as image first. Okay, so I usually would save all my files as EBS, as encapsulated something. Now, those are very good, especially when you are working with LaTeX, because it preserves the sharpness and the colors and the quite intact. Everything is intact. Okay, if you copy, let's say you screenshot and so forth, by the time you have it in it is a bit blurred. And then when you print it out, nobody can see. So in now, you must always save your original file and then you copy from it. Okay. Now here is the directory. If you see here, you see that my directory is already set because I went to what we did last week and then I opened it. Other than that, I need to go and search. If you just press and save, it will go and save in your document. And then when you are searching for it, you can't find it. Is that okay? So always, that's why we created a folder. You must let R reside in that folder when you are working, which means you have to open R from that folder. Okay. All right. So then it gives you the first option to save in that folder. So here I can just give it a name like bar plot, maybe 1. So if it is Fs, if you don't have Fs, you won't be able to use it because you need a special, also a program to open it. I think the normal what you use in Windows will not be able to open it. But other than that, you can use PNG. That's also a good way of saving PNG than JPEG. And then you click on save. So if I go to this, you see bar plot 1 is there. And if I click on it, I have it like this. Okay. So that's it. That's a bar plot. Okay, you see it looks very nice. So if I want this in Word, I can copy it from here. Copy. And then I go to Word. And then I save it. Like this. So if you look at this one, you see where the plot is. It fills almost every area. This is unlike when you do something in Excel or SPSS. The graph will be sitting somewhere and all the area. So you see, when you write, it's only here you cannot write. So that's why I stopped that part. Okay, or I closed that gap. Okay, so this, your image space is exactly the same as what you want to portray. So that's it. This is a good way of getting your file, your graphs into your Word document. Okay. If you use a clipboard, copy into the clipboard, sometimes when you paste it, it's too wide. And then you now try to resize. No, we don't resize this. In LaTeX, you save it, we'll read the image straight away. And as I said, I think I'll tell them, but then we run it for you. Because now we are also held up during the weekends for our courses. So, okay, is everybody okay? Are we okay how to remove, how to save files? How to save it? Okay. Now we are yet to do, let's do another thing. Okay, yes.
It's like information overload.
Hey,
We have passed our time.
you've passed your time now.
Yes.
Oh.
You want to digest.
This one, oh, this one, your digestive system will break it.
Let's digest it.
Okay, all right. So I even need rest before my next class. Yes. So yeah, please continue with the video. When you finish with the bar, I think you have to install portraits package or so. That will give you 3D graphs for the pie chart, how to explode it, and so forth. Then when you are done, you go to the histogram to box plot. That will walk you through quantitative data, histogram, box plot, stem and leaf, those kind of things. You need all those for your data analysis. All right. Enjoy the rest of the day.
Looking forward to
Which one?